Hey people, welcome back. And today we are going to learn the process capability of continuous data when data is not normally distributed. So I'll tell you the process, how to calculate the process capability for the not normal data. So let's generate some data. Suppose let's say this is the data for your transaction time or any other time or any other unit of measurement, whatever you want to take is the data. You are collecting the data for last couple of days and I'm generating some random data. Maybe you are taking around time, which is maybe 20 to 30, 20 to 30 minutes, let's say 20, 29 plus some random values. And this data you have collected for last couple of days. I have generated last 20 days of data, right? Let's see either this data is normal or not normal, or we'll try to make this data as a not normal. Maybe some values will change in case this data comes out to be a normal data. So how to check the normality of the data? We will just copy paste this data in Minitab, and I'm opening the Minitab software where we do this analysis. So now Minitab is here. I open the data window and I'm pasting this data. First thing, what do we do? Let's check the data is normal or not normally distributed. So we'll go to the Anderson-Darling test. Path is stat, basic statistics, and here is the normality test. Click on this, select your data, click on OK, and now you see the image. And luckily, this data came out to be not normal. How to identify data is normal or not normal? This is the Anderson-Darling test we perform. And we look at the p-value, or if the p-value of the data is less than 0.05, then this data is not normally distributed. So step number 1 we have completed. Now the step number 2 will be, if this data is not normal, then what distribution this data is following. So we will be checking the distribution of the data by looking at the individual distribution identification. We'll go to the stat, quality tool, and here is the option individual distribution identification. Click on this, select your data, subgroup size by 1, and leave the rest of the setting as it is. Select all the distribution, use all distribution and transformation, and click on OK. And once you click on OK, you will find so many of the statistical distribution graph is plotted here by the Minitab. No need to worry about anything. Just directly jump into the goodness of fit table, which is this. And here at the goodness of fit table, whichever the p-value is greater than 0.05 and is the highest, that distribution your data is following. Except normal, because it's already not normal, so p-value will be less than 0.05. And your Minitab will suggest you in case you are looking for the transformation. So you have the two transformation. One is the box cost transformation, which we generally use for the control chart plotting transformation. And you have the Johnson transformation, which we use for the process capability. But because my data is not normal and I don't want to transform this data, so we'll be using the data as it is. And now I look for the highest p-value. So I can see as per this data, the only one p-value which is greater than 0.05, which is your two-parametric exponential. So when I'm calculating my process capability, I look at the highest p-value except transformation. And my highest p-value here is two-parametric exponential. So I will be using this two-parametric exponential for the process capability calculation. So looking at this data, if I select two-parametric exponential, so how do we go this? Let's say, now I will go for the stat, quality tool, capability analysis, and here is the option not normal. Select this capability analysis not normal, click on this. Now you select your data, transaction time. Lower specification, as we remember, we generated the data between 20 and 30. So let it be 20 and 30. And the transformation I have to select, you can see it's a 2-parametric exponential. So when you drop down the fit distribution, you will be selecting the 2-parametric exponential. So all the distribution is given here. Whichever the distribution your data will present with the highest p-value, that distribution you will be selecting from this drop down. So I have 2-parametric exponential, and the 2-parametric exponential is this. Click on this. 2-parametric exponential selected. Click on OK. And here is the output. So looking at this data, my PP value 0.59, PPL 0.82, PPU 0.36, and PPK is 0.36. And here is the how much is the ppm parts per million, less than lower specification and more than upper specification, or total parts per million are given here. This is the way we select, and this you can see calculation based on the exponential distribution model. In case you don't want to see PP or the ppm, you wanted to see like a z value, or maybe you are looking for the DPMO. So just edit this graph by pressing Ctrl E. Go to the options. In options, you can select, instead of process capability CPPP, you want to see the benchmark sigma value, or instead of parts per million, you want to see the percentage data. Just select this, click on OK, click on OK, and here is your Z bench is 1.06, Z LSL 2.46, Z USL 0.109, and PPK value 0.36. And here is the data, how much data is falling below or above the lower and the upper specification limit. In case you want to calculate the same capability in Excel, so what we'll be doing? Let me tell you. So first you calculate PP. Please remember, for the normal data, we can calculate CP and PP both. But when data is not normal, we generally or always calculate the PP only. Then we'll calculate PPKU, PPKL, and the lowest value out of this will be your PPK. And then you will be converting this into the ZUSL, then ZLSL. Then you will be making the yield, USL, and the yield LSL. Then you will be finding the defect on the upper side of a specification. Then you will be finding the defect on the lower side of a specification. Then you will find the total defect. Then you will be converting this into the final yield. And then you will be converting this into the Z bench, which is sigma level. This is the process we'll follow. All right. So suppose my specification is, let's say, USL, or let's say first LSL is 20. USL I identified as in 30. I need average value, which is the mean value. Let's calculate, simple, use the formula average, and here we select. So I got the average value as in 25.02, and the standard deviation of this data is equal to STDEV.S, and here are my numbers. So standard deviation, these are the minimum thing which I need to calculate a process capability. Now PP value, you know the formula. PP is always USL minus LSL divided by 6 times of standard deviation. This formula will be using here. So you want to convert into the PP now. So PP value will be is equal to USL is 30 minus LSL is 20 and divide by 6 times of standard deviation, and this value is 3.51. So my PP value is 0.47. I calculate PPU. PPKU is equal to USL minus mean divided by 3 times of standard deviation. So what will be my answer? My answer will be for the PPKU is equal to USL is 30 minus mean value is 20.02 bracket, then divide by 3 times of standard deviation. It is 0.47 approximately. Now I'll calculate the PPKU. PPKU will calculate by PPKU we calculated, sorry, PPKL. So formula for PPKL is mean minus LSL divided by 3 times of standard deviation. So in this case, if I put this formula, so my average value is 25.02 minus lower specification is 20. If I divide by 3 times of standard deviation, so my PPKL will be done, which is around 0.47 in this case. Almost same value is coming. In case we want to change some data, let's say this 21, if I make it to, let's say, on the lower side to make it to upper side, maybe 29. So now these values are changed. This become 0.47, this became 0.43, this became 0.58. Average has moved to the upper side and the standard deviation is also changed. Just to show you the difference that these value cannot be same always. It can be different as well. So just to give you that understanding, I changed one value and all the values are changed. Now the PPK is the minimum value of PPKL and PPKU. So whichever is the PPKU or PPKL you have, that will be this value. So if I select here minimum and I select the PPKL and PPKU, so my 0.43 is the minimum value. ZUSL is your PPKU and multiplied by 3 will become your Z value. And similar way, if you have the PPKL and you multiply this by 3, that will be your ZLSL. So PPKU is 0.43. I multiply this by 3. I got around 1.28. And PPKL is 0.51. I multiply this by 3 and I got this value, 1.5. Once I got the Z values, I will convert that into yield percentage. So yield percentage, whenever you are converting sigma into the yield, we use the Excel formula norm S dist. This formula will be using. So I'm using this formula is equal to norm S dist, selecting your sigma 1.28 on the upper side of a specification. So that means around 90% data will be less than the upper specification limit. Similarly, on the lower side, same formula I will use, norm S dist, and 1.52 means around 93.56% data will be above the lower specification limit. So how much is the defect? Defect is always 1 minus yield. Correct? So if you are using the formula 1 minus yield, so my 1 minus yield is 90.04%. So this yield defect will be how much? 9.95% are my defect. Because 9.96, 100% minus 90.04% is 9.96. In the similar way, if I convert 1 minus 93.57, so then this answer will be 6.43%. These are my defect on the lower and the upper side. Now, the next thing what I should do, I should be calculating how much are the total defect. So total defect is the sum of defect on both the side. Defect if you take the sum. So my defect on the lower side is 6.43, defect on the upper side is 9.96, and the sum for both is 16.39. So final yield is 1 minus total defect, then is equal to 1 minus total defect, which is coming around 83.61%. So Z bench, when you convert the probability into the sigma, we use the formula norm sine V. So here, my formula I am using norm sine V. And here is my 83.61. And if you see this value is around 0.97 sigma. This is how we calculate the process capability in Excel all the Z values in Excel, percentage in Excel, defect in Excel, and I explained you in the Minitab as well. So I change this first value. Let me see, because the first value if I change, so Minitab value will not match. So I will just do one thing. I'll match this value here. First value I'm replacing. Okay. And here we go. And now I want to calculate my capability here. Same data is there. And he will click on OK. So Z bench here is coming around 0.96. Z LSL 2.32. Z USL 1. And approximately same, because Minitab is more powerful software which is using the specific distribution, but approximately same value of the Z bench or Z LSL and Z USL we are getting here with this data. All right. Thank you so much, and I'll see you in the next session.